Hi, I'm Steve Matthews with ACOM. Today we're going to demonstrate a horizontal shaft alignment with the NXA. First thing you'll notice is this is a touch screen, and so we'll select the horizontal shaft alignment program. There's a number of other programs on an NXA for addressing just about any alignment condition that you might have. Today we're going to do a horizontal shaft alignment. So now that I'm in the horizontal shaft alignment program, we'll address a couple of things with the setup. Number one is we've got a demonstrator that's meant to represent a driven machine and a driving machine. We also call that stationary and movable. And so our sensors are designated as such, S and M. Another thing to notice real quick about the sensor setup is that my adjustment or aiming the lasers setup is simply done by moving the sensor up and down on the post and clipping it in place. This is easily done with the bright line lasers and a large detector. The detector is also digital, which helps with sunlight filtering if you happen to be doing alignments outside. Now, we've got the sensor set up on the stationary and movable, and we'll move into the alignment process. So the first thing to do in the alignment process is take the dimensions of the machine. So with our Guide You user interface, it will ask you with guidance step by step what to do next. So here the first measurement is from sensor to sensor. In this case we have 205 millimeters. The next measurement is from the movable sensor to the center of the coupling, which is 95 millimeters. Next, from the M sensor to the front feet of the movable machine, and that is 0. And then front feet to rear feet of the movable machine, and that is 175. Now that I've got the dimensions in, next step is to select a tolerance. Shaft alignment tolerances are generally based on machine speed. So we'll pick the 2000 to 3000 tolerance, hit the check mark, and now I'm ready to begin my measurements. I want to just explain what the process is going to be before I go through it. We'll take a set of measurements and then we'll do what we call a vertical alignment. That's where we do a vertical and a horizontal adjustment at the same time. What this process does is reduce the amount of effort in loosening and tightening machine bolts and making multiple adjustments. So if we've done a good job correcting for things like saw foot at the beginning, we should be able to get an alignment done in 1 or 2 adjustments. What you'll see here is that the alignment process starts automatically. Now this is helpful in the case where you may be doing an alignment job by yourself. We can start anywhere and stop anywhere on the shaft rotation. And when you see that little target, it's taking a set of measurements. It's actually taking a lot of measurements simultaneously to filter out any potential environmental vibration. Now on my third and final measurement, you'll see the measurement results. Red means it's out of tolerance, green means it's in tolerance. There's also a yellow or orange icon for close to tolerance. So what you'll see in the vertical alignment, both my angle and offset are out of tolerance, and in the horizontal, the angle is okay, but the offset is also out of tolerance. So now I need to make an adjustment. Again, a horizontal adjustment where we go straight to the shimming. And again, our Guide You user interface is very good at prompting the user what the next step is. In this case, we don't have to decide whether we're taking shims out or putting shims in based on positive and negative numbers, but it's very clearly marked. Arrows going in means we're adding shims. This demonstrator was set up in such a way that it would be misaligned so we could do an alignment. Now, as I loosen the bolts and prepare my shims for the adjustment exactly as I see here. We will add the rear feet. .35 millimeters, and the front feet 80 millimeters. Now again, with a vertical alignment, I'm not going to tighten the bolts down at this point. I'm going to go straight to my horizontal adjustment and make that adjustment before tightening the machine bolts down. And you'll see in the horizontal adjustment that my arrows are scaled for how far I need to move. And again, I'm shooting for a tolerance of 0.07 and 0.07. And you'll see that when I move the feet far enough, according to the scaled arrows, that we achieve our alignment tolerance. At that point, I can tighten the bolts down. And before I go on and remeasure to double check, I just want to show real quick a feature that we call OmniView. And what OmniView does is orient the picture towards which side of the machine that the user's on. So generally maintenance teams are working in groups of 2 or more. And so my partner may be on the other side of the machine, which is the way the picture's oriented towards the camera now. But if my partner passes the NXA over to me, I can see the picture from my side of the screen. And then as I put this back in the camera shot, you'll see it reorients towards your view on the other side. So that's what we call OmniView, and it makes it a lot easier to know which way to move the machine back and forth when you're conducting the horizontal part of the alignment. So now that we are completed, we will remeasure and document our alignment. The measurements begin automatically. And again, we start anywhere, stop anywhere on the shaft rotation, as long as each of the measurements moves outside of the little red zone you see on the screen. So now I've taken my measurements to confirm my alignment is completed, which it is because I have a green check in the vertical and a green check in the horizontal. So my alignment is done to 2,000 to 3,000 RPM tolerances. And at this point, we can document this alignment in a number of different formats, either PDF or text file, or JPEG. And so the alignment report can then be transferred in a number of different ways.